Hi everybody, welcome to this video. In this we are going to talk about how to plot linear equations. First of all, I'll remind you, if you want to recap what linear equations are, how do they look like, you can watch this video which is shown on the slides, and I'll put its link in the description beneath the video as well. Now, what the video is going to talk about is going to introduce you to what the equation of a linear function looks like. It is going to introduce you to what a dependent variable is, what is independent variable, what is the gradient or slope of a linear function, and what does the y-intercept, which is represented by c. So if you want to brush up on those topics, please go and watch that video again. Okay, so let's come to today's topic, which is plotting linear equations. So suppose we want to plot a linear equation which is y equals 3 minus 2x. Now we know that the general equation of a line is y equals mx plus c, but the above equation doesn't look like that. So we can rearrange the equation to see the equivalence. So we rewrite it as y equals minus 2x plus 3. Note this rewrite is not necessary to plot the line. It's only to see that it still matches with the general equation. Remember, as we discussed earlier, the constant 3, which represents c in the general equation, is where the line crosses y-axis. Now, when it crosses y-axis, we also notice that the value of x at that point equals 0. So therefore, we can work out a point that is when x equals 0, we can substitute it into our equation y equals minus 2x plus 3, and it turns out that y equals 3. So we can calculate it from the equation. So to plot the line, we must choose a range of x values. And it's reasonable to choose some negative values and some positive values. So let's say we decide that x will range from minus 3 to plus 3. Now let's start computing pairs of x and y's to decide the points that we want to plot on our graph. So yeah, we create this table where we have a row for x, and then we also compute minus 2x as an intermediate computation, and finally we'll compute our y. So when x equals minus 3, minus 2x computes plus 6, and minus 2x plus 3 amounts to 9. If you are not sure, you can pause the video and calculate it for yourself. Similarly, when x equals minus 2, minus 2x evaluates to plus 4, and y evaluates to plus 7. And yeah, so on, we can continue working out other points, and we can get a whole range of points. Now that we have all the points, we can draw the graph. So we must have an xy plane with scales on each axis suitably chosen. But before we do that, I've just sort of removed or hidden the intermediate value, so it's easy for you to see that what pairs of values we are going to plot. So only the x value and the corresponding y values are now remaining on your slide. So we can start off by plotting the first point. As you can see, we draw a temporary line starting at x equals minus 3, and we go up until we reach y equals 9. And this way we keep drawing the points. So we repeat this for all the other points as is shown in the video that you just saw. Once all the points are drawn, we connected them, and we got a whole line. Now here's another example with a new equation, y equals half times x minus 4. Again, c represents y-intercept, That is where the location where the line crosses y-axis. But in this equation, c is not clearly visible. It's not visible straight away because it's still not in the form of the general equation. If you want to know what c is, you'll have to turn it into the form y equals mx plus c by multiplying x minus 4 with half. You'll have to open the brackets. Now, since the y-intercept appears on y-axis, it is easy to see that the x-coordinate will have to be 0, as before. So we set x equals 0 in the equation at the top of the slide to work out y-intercept. And when we do that, y turns out to be minus 2. So we can mark that as a point, which can be written as 0, comma minus 2, where x-coordinate equals 0 and the y-coordinate equals minus 2. So a point is made of two coordinates. The first one is called the x-coordinate and the second one is called the y-coordinate. So we have got one of our points, okay? But like we did in the last slide, we must choose multiple other points to draw the line reliably. So we choose a range of values from -3 to 5 in this case. And again, we tabulate those values. So they're all shown on the slide, but I suggest you can pause the video here and calculate those values manually to convince yourselves that they have been computed correctly. And then once we have all these values, again, I just hide the intermediate computation to leave you with just the x-y pairs. And now we can plot the graphs. So I've just quickly plotted the graph for you. It's there for your verification. I've just highlighted 2 points here, but you can work out the remaining points as well by plotting all of them on a piece of paper. And this will be there. This graph will be there to verify whether you have correctly drawn the graph or not. Now, so that concludes the video on plotting linear equations. In the next one, we shall try to rediscover the equation where the graph is already given to us, but the equation isn't. So we'll see you then.